Hello all and welcome back to Money Makes Games. Today I want to do a little beginner series about how to make your first game. Our game's going to be based on Pong, which is one of the original video games that started the industry, so I thought it would be quite fitting. Are you ready to come with me? Then let's do this. My name is Moni and I make games. Now to start off with, we're going to open up the Unity Hub and we'll say new project. My Pong is going to be in 2D because we're keeping it simple. And it won't be exactly like Pong, so we'll call it Pong-ish. Okay, now Pong-ish is going to be a 2D game. I would recommend we do 2D URP for your universal render pipeline, but you can also do this in 2D core if you want to. Our editor version is going to be Unity 2022.3.1. That's an LTS release, which means it's going to be supported for a while to come. Right, create the project. Now while that's creating in the background, let's go over this game design document that I set up for us. What we want is we want a Pong-like game. So that would be two players opposite one another hitting a ball like tennis. If the one misses, the other player scores a point. First with 10 points wins. That just establishes our win condition and the ground rules. I've set up player 1 to be at the bottom and player 2 is going to be at the top. And we'll have the ball spawn in front of a random player after each point is scored. Why do we do a game design document like this? It's basically just so that we know what we want and where we're going, because that makes it easier. When you've got this description of the game down, you know that you're going to need two players that can deflect a ball when the ball hits them. You know that the ball needs to move. You know that the ball needs to be spawned. You know when it needs to be spawned and where. Okay, so what are the elements we're going to need here? As I've said, we'll need the players. Now, my player's only going to move left and right, or in this case, actually up and down. The player has to stay inside the limits of the play area, and it has to have a collider for the ball to bounce off. But we won't need a rigid body. Now if you don't know what those things are, don't worry, we're going to cover that as we go. For the ball, we need to apply a force to the ball to launch it initially, and we need to be able to position the ball at the player's launch position. That means that the ball will have to have a collider so it can bounce off stuff and hit stuff, but it will also need a rigid body so that it can have forces act on it and have momentum. Then we've got a scoring trigger. This is basically how we're going to detect when the ball has gotten past the player so that the other player can score. Then we've got our game manager. The game manager's job is going to be to update the score when notified by the scoring triggers, to spawn players, and to start the game and reset after one player wins. Then we've got a sound controller that's just going to do those little buzzes that you get when you miss, and the sound when the ball hits the player. And of course, maybe play a little dirty when we lose or win. And then we've got our navigation manager, which is basically just going to take us from our menu to our play scene and to the end scene, and then back to the menu so we can start again. Alright, now that we've got that planned out, I'm pretty sure our project has started in the background. It hasn't. I'm going to pause here until it's done. I'll see you in a bit. And we're back. Okay, now what you can see here is a basic 2D starter scene for Unity. Because we're working in URP, there's a light in here. And there's a main camera, which is basically going to be the camera that renders that renders the action for us. And here is our scene name. So let's start by renaming our scene, because at the end of the day we want different scenes. We want a scene for our game. We also want a scene for our menu and for our end screen. So if we go to assets and screens, you can click down here and we'll call this game scene. Okay, we can confirm up here that it's changed. We've got our game scene. Now we want to keep this simple. We want a simple black background, and for now we just want players that are flat white rectangles with flat white borders around, and that's about it. That's all we want. Our ball should also be a flat white circle, and then later on, when we've got a game and the gameplay is good, you can actually go out and insert nice graphics and personalize it the way you want. Okay, let's start. We're going to go in here and we right click and we say 2D object, sprites, and we're just going to go for a normal rectangle right now, or a square. I'll grab my square and I'm going to make it as big as I can. And we'll go over here in the inspector. This is where the property of your game object is. We'll click and we'll drag the color all the way down there to black. If you prefer a more tennis-like feel, you can go for a green. But I'm going to go for the original Pong feel right now and just go black all the way. Right, now that we've got that, let's create our ball. Let's just name this quickly. It helps if you name your stuff in a way that makes sense, because then it's easier to find it in your hierarchy when it gets complicated. So we'll call this square our background. And then we'll create another 2D object, sprite. We'll make that a circle. We'll call it ball. And we'll create another one. And we're going to call this one player. Okay, now let's grab player. Click here so you can use the rectangle tool on player. And we can shape our player that we want him to. And let's just move the player over here. And there we've got our ball, our background, and our player. Right now they're not doing anything. So let's start to get the ball rolling. Or in this case, bouncing. The first thing we're going to do is grab our ball. And we're going to add two things to it. Now, if you look at our game planning over here, we mentioned that the ball needs to have a force applied to it to get it moving at launch. And it needs to be able to position itself at the player's launch position. So that means we're going to have to basically attach something to the ball to tell it what to do. This is going to be a script. In our case, a mono behavior. And the ball also needs a collider and a rigid body. Now, a collider is basically a component to a game object that detects when it hits something with another collider and takes the appropriate action by bouncing it back, just not allowing it to go through, or I don't know. I'm kind of stuck here. All right. That was just a moment. Let's add those components that we need. First, let's start with our rigid body. Now in Unity you get two types of rigid bodies. You get the rigid body 2D and you get the 3D one. The 3D rigid body operates in three-dimensional space, while the 2D one saves a bit of resources by only worrying about the X and Y coordinates and everything that happens in those directions, while the Z completely gets ignored. Now, rigid bodies, you get different types. You get a dynamic rigid body, kinematic, and static. So, a kinematic rigid body will, if it hits something, it will apply a force to that object. And if it can be moved, it will move the object that it hits. But the kinematic rigid body itself cannot be moved by getting hit by something. That's the easiest way for me to explain it. A dynamic rigid body, on the other hand, is moved by stuff as well as being able to move other stuff. So if you have a kinematic rigid body, it can be affected by forces such as gravity or being run into by any kind of object. And then we've got a static rigid body. A static rigid body basically just sits there, and if something hits it, it will deflect that object, but it will not be affected itself. Right. On your rigid body, you can apply a material. We won't be doing that right now, but we will talk about it a little later. Simulator just means that it's turned on and it's doing what it's supposed to do. Now down here, we can set the mass for our rigid body. I'm going to leave my ball at 1 kilogram, which might be a little heavy, but that's okay. Our linear drag is going to be 0. We don't want any drag on our ball because we don't want it to slow down. The angular drag is basically when the ball rotates, how quickly it stops rotating. In other words, the drag that slows it down from spinning all the time. And then we've got our gravity scale. This is how much gravity affects it. So gravity is usually about 9.8 meters per second in the down direction, which for us would be a negative y. That means that if you have a gravity scale of 1, it's going to be affected normally and accelerate at 9.8 meters per second downwards. If I were to have a gravity scale of 2, it will accelerate twice as quickly, or 0.5, half as quickly. And interestingly enough, if we have a negative gravity scale, I suspect our ball will go flying up into the air. Why don't we test this? Now let's press play. And there our ball is falling. Now you notice two things here quickly. Firstly, notice that we couldn't actually see our ball until it went past our background. Now I'm thinking this is not ideal for playing Pong, so how do we fix this? Well, this is a good time to talk about our sprite renderer and to talk about layers or sorting layers. Now, Unity has sorting layers that determines which sprite gets shown in front of which other sprites. And then within that layer, in that sorting layer, it also has orders in the layer. So the bigger the number here, the closer the object virtually is to the camera. So if my background is on 0 and I put my ball on 1, the ball's going to show up in front of the background. If you want to do something a bit more involved, where you've got multiple objects that need to line up and some of them belong to the background and some belong to the foreground, then it's good to actually use sorting layers where you can add an extra layer. Now, this is my default layer. If I add a new layer below that, that means it's going to actually show in front of it. So let's just make one and call that foreground. Okay, so now we've got the foreground. We need to go back, click our ball. I'll set that to 0 again. You see it's invisible, but if it's on 0 in the foreground, it still shows up in front of the background. Even if I take this background here and I make that 10, it's only number 10 in that background layer, which means it still won't show up in front of anything that's on the foreground. Okay, let's do the same for our player while we're here. Move our player to the foreground. Now everybody can be seen. Okay, let's get back and have a look at our rigid body. Now we saw it falling down with a gravity scale of 1. Just for kicks, let's make it -1 and see what happens. As you can see, it just shoots up into the air. Okay, we're going to talk about why it shoots up a little bit later. It has to do with vectors. If you're unfamiliar with vectors, I would suggest you look them up. It's good to know vector math if you're doing games. But for now, we should be able to get along just fine with what we know. Right, now we've got our rigid body. We also want a collider. This is a circle, so it's probably going to be a circle collider. I say add component, circle collider 2D. That's very important. Always, if you're working in 2D, use the 2D variants of colliders. Otherwise, you will get unexpected results and you might not get the collisions that you want or need. Okay, I've got a collider, but now my ball can fall and just basically fall off the screen and nothing's going to happen, which doesn't make for a nice game. Now, initially, let's take our player and just drop the ball on top of the player. I've got my player here. We're going to go in the transform. Look at the rotation for our player. We want to rotate around the Z-axis. Now the Z-axis is basically the axis going straight into the screen. If you look at this little widget here that we use to control our position, you'll see an arrow pointing up. That's our Y. You'll see the red arrow pointing to the right. That's our X. And then there's an arrow that is actually pointing straight into this scene. That's our Z. So we want to rotate around our Z position like this. If you were to rotate this, which is actually a 3D object, around the X, you'll see it starts to look like it's getting smaller from our perspective. That's basically because you're just facing it straight on, and it is rotating until the flat side faces you and it seems to have disappeared. This is just to help you understand how the rotation works and what the axes look like. Now we're going to rotate this to 90. Not 900. Put it over here. Now you can see the ball has a rigid body and a circle collider, but there's no collider on our player. So what would you guess is going to happen right now? That's right. Nothing. The ball's just going to fall straight through our player. So to stop that from happening, I'm going to put a box collider 2D on my player. Now, if you have your box collider and you want to change it, in other words, change the dimensions of it, you can go in your collider, go to Edit Collider, and if you click that button, you'll see you can actually drag the collider with your handles to be a different shape. So what's going to happen if I press play right now? Well, our ball's going to come, fall down, hit the collider, and stop. Maybe bounce a little bit. Let's demonstrate. You can use this to your advantage in some games, but it's also something you need to be aware of, because obviously this isn't going to look very good in your Pong game if the ball actually stops before hitting the paddle. Okay, so let's move our collider down. Notice that we're currently in play mode. So if I make a change on the screen here, in play mode, it's actually not going to get stored. So if I correct this and exit play mode, my collider just bounces back. Always keep this in mind. It's useful for experimenting with stuff, but it can also be a bit of a pain if you forget that you're in play mode and you start building out a scene. Okay, now let's press Ctrl S to save. Always important. So we have a ball, we have a player. The ball can hit the player and the player can deflect the ball. What's next for us? Well, we want the player, the ball to actually bounce off the player, because if it just deadens the collision every time, that means you're going to start losing speed, and pretty soon your game's going to die and the ball's going to stop. So let's talk about materials. Right. So here's my ball. And in my collider, I can set a material for it. Now currently we don't have one. So let's create a physics material. First, I'm going to create a folder. When you're doing projects, it's always important to stay organized, because as your projects get bigger, it becomes harder and harder to find stuff, and you're going to find yourself wasting more and more time just trying to get stuff done. Okay, so we create. And let's find our physics material. Here we go, almost at the bottom. We'll call this ball I'm going to call that my ball physics material. Now, if you have the material selected over here, you'll see some properties. First, you've got dynamic friction. And if you mouse over this, it actually gives you a nice little explanation that says, this is how much friction the collider surface has when moving while in contact with another collider. In other words, this is the friction while it's moving. The static friction is how much friction it actually has when stationary while in contact with another collider. Now, it might seem like this is the same thing, but basically what they're saying is if the ball's standing still, this is how much it's going to resist getting moving, physics aside. And if it's moving, this is how keen it's going to be to keep moving or to slow down. So the higher the dynamic friction, the quicker it will slow down. The higher the static friction, the harder it will be to get the ball moving if you push it along a surface. Think of a box where a high friction box would have rubber at the bottom. Of course, this breaks down because when it's moving, it's the same thing. Right, moving on before I embarrass myself any further. We've got bounciness here. Okay, now bounciness is basically how much it rebounds after each hit. So if I have a bounciness of 0, my ball's going to hit the paddle and just stay there. It's going to lose all the energy in that collision. If I have a bounciness of 1, it's going to return all the energy and basically keep doing the same thing. So in other words, it's not slowing down, it's also not going faster. Let's play with this. First, let's do, oh wait, I haven't assigned the material yet. So let's exit play mode. So let's click on our ball. And we go physics material right there. Drag it in. Come on. Now that seems to be an issue. Why? Common mistake. I made a physics material, not a physics material 2D. Let's see if we can fix that. Okay, so I went to create and I went down to physics material, but that's for 3D objects. So we go to 2D and we go physics material 2D. There we go. Okay, we'll call that ball physics mat. We'll delete 3D one we don't need. Now we can do our little experiment. Okay, as you can see, the friction is much simpler on a 2D ball. So it's basically just, this is the friction. The higher the number, the more the friction. The lower the number, the less friction it has, and therefore will slow down less slowly. And then the bounciness is as we talked about before. So let's grab our ball and we'll assign our material to it. Okay, so now we have our material assigned to the ball, which means it will affect how the collisions on it work. Let's see. Here's our friction. Friction is 4. Which should slow down our ball as it moves. And we've got our bounciness. Let's see what happens. So, now, as you can see, it basically just thudded down onto the paddle and nothing else happened. Now, let's do the complete opposite. Let's make our bounciness 1. Now, as you can see, it basically gives back all the energy it had, and it actually adds a little bit. Now let's try, just for kicks, let's make that 1.5 and see what happens. Now, as you can see, it actually gives back a lot more of the energy. And if you made that 0.8, each bounce should be a little lower than the one before. And there we go. Now you can choose how you tune your bounce depending on what kind of game you want. In our case, we want the bounce to give back as much as it can. In fact, why don't we make it go a little faster over time and see what happens with our game. Alright, this video is running on 30 minutes already, so I'm going to cut it off here, and when we come back, we'll do the part where we actually add our second player. We'll add some boundaries, and we'll add a force to the ball. Until then, my name is Mani, and I make games.